Welcome to our podcast today. Today we are together with Professor Dr. Sebastian Bayerl from the University of Applied Science Rosenheim, and our topic is AI and the power of learning. Welcome, Sebastian.
Hi, Marc. Thanks for having me.
Of course, I was discussing with you up front. One was the time when we met together, and we was discussing it is 10 years ago, and you said it's exactly 2016, I guess, no?
Beginning 2016, I think March or something along those lines.
Yeah, cool.
It's been
That
a
was
while.
a while, and I think it's not just a while; it is also a wild ride since then. And we was really in close contact over the last 9 years, and it was amazing for me how you developed in these years. And I would like to have today your expertise is also in the university. You are now a professor there, and you are working quite a lot in the field of you are working in the faculty of computer science, and you're specialized in speech processing, pathological speech processing, natural language processing, speech recognition, and applied artificial intelligence. And you are really a nerd deep dive into this world. And for me, I'm more in the business world and working there. And today I want to bring these two worlds together. But the most interesting part for me is how you developed your own neutral network in your brain, because this is amazing what humans are capable. And this is something I would like to highlight today. Can you tell me a bit maybe about your life story, where you started in your educational journey? What was the biggest things in your last 20 years? This is really interesting for me.
Sure. Well, we can start at the very beginning, and then we'll talk about when we met, because this is where I was pretty much at the crossroads. Crossroads of, you said you're in the business side of things, and if I can remember correctly, when we met, I was also more interested in the business side of things. And then things turned sideways, so to say, where I made a 180 and went deeper into the technical side of things. But for the whole journey, as you know, listeners don't, I started out as someone who had to quit university on the first attempt when I was trying to study information techniques, electrical computer electrical engineering. No, what's it called? Electrical engineering. That's it. And I quit after 1 year and decided I had to do something else. Which in Germany, one option is you go to vocational training. So I started vocational training as a system administrator, basically. And after like the 3 years-ish of vocational training, I became a team leader, but universities actually always stuck with me. So after working in the field for 2 years, I decided to go back to university, do business informatics or computer science with a focus on business. And which was very, very valuable for me. And this is where we met, at least during the masters, which we had a shared course on interaction design, if I remember correctly.
Yes.
And ever since, academia stuck with me, because after quite some time in the uni, I felt like I want to be there for longer and do some teaching. At least that was the focus back then. And yeah.
Was it always easy for you to learn? Because are you a fast learner? Are you an easy learner? Is it something you do quite well, or is it hard for you?
I would say I'm an average learner. Not the fastest, not the slowest. But what always stuck with me that I just need to sit down and I need to take time and make time to learn. A lot of that at the beginning of my studies in computer science were fear driven. Because I always, in the back of my mind, there was like me not doing too great in electrical engineering. And so I was really afraid. And so every Friday that I kept my old job during that time, at least for 20 to 30 hours, and went full time to the uni. So my days were very structured. Started off, go to uni, then go to work. Uni, work. Alternate between two things. And Friday evening, or when I came home from work, it was at lunch or at dinner. Then sat down, and then it was math. Was my first topic all the time, and then programming. And once I finished all the assignments for the week, this is when I stopped, or at least told myself I would continue next day. So Saturday usually was also studying, and Sunday was mostly leisurely, but a very structured week, so to say.
Is this something you kept all the semesters until you did the master? Or is that something that you figured out on the way that changed a bit because you're getting better in the way of learning?
I kept a couple of the things, especially with the basic stuff, because basics, there's just no way around, at least for me, to sit down and do it, right? Yes. There's exercise sheets, and you just need to do the exercise sheets.
Yes.
And I always have in the back of my mind, one of my first math professors I had during the electrical engineering part, Professor Petrie. He was saying something along the lines of, math is more doing than science, especially when you're learning, right? And this always stuck with me. So for those mathy subjects, it's all about sitting down, learning, and then doing it. For other things, I didn't do it that way anymore. It was mostly like experience driven. So when you had a project, you just had to apply, for example, which was different, I would say.
Did you need it the nights also for learning? Or is it something I don't know. In the last times when we called, I think also in every call when we just met and met some time ago, I always said, what's going on your side? And you said, I have to finish something, I need to work at night. And it's something, and I think for us it's normal, no? But for the younger generations or people who just maybe has everything fallen easily to them in the life, and they had understand everything quite easy. It was never in my case the path I go, and so I needed to sit down. Also, it was sometimes brute force to learn. I needed to brute force through the way and to get the things inside my brain and understand the logic behind. And but this shaped my neural network, I think. And this is something I would like also to discuss with you. Is, do you think your brain has changed in this? I think, how long did you study it? Bachelor and master together?
Like 5-ish years.
Yeah. And do you think this changed your brain structure?
Absolutely. I mean, that's biggest recommendation I have to give to everyone who starts at new. Doing hard stuff changes you. Yes. And you shouldn't take the shortcuts. There's too many shortcuts these days, but there's no shortcut to shaping your brain by doing hard things. Once you lose the ability to do hard things by yourself, everything else just, I mean, it doesn't fall into place. Your worth, especially when we're later talking about AI, doesn't come from you using tools. Your worth comes from you being able to use the tools with your brain that can still do hard things, and then combine what you get from the tools. Like a CEO, right? CEO also gets stuff from their employees. He doesn't have to do it himself, but he must be able to still understand what happens, what went into doing this, and so on. Then he can make decisions or informed decisions.
And do you think that the capabilities of us humans is our brain, of course, you already told us, but another capability of us humans is to learn to work with each other? And did you figure out some interesting learnings from your side in the time when you studied with your colleagues, with your peer group together in the university, how you can connect your brains? That this is something what you think is value to share?
I think it's a valuable skill, but I really didn't learn that too much during the uni, at least not during the bachelor's or the master's. I was so focused on working because I had to come up with the money for my living expenses and studying. So I was always in kind of on my own as long as it's possible. And in group projects, if someone just didn't perform, I just took over for them, right? It's just pushing through because I wanted to get this done. I was already mid-20s until my early 30s.
Yeah.
So I had to get this done. I had to get a degree and I wanted to continue. So I didn't really care to do the work of others in a group project if they didn't do it. I needed it, so I did it. And that was just something I learned later on during my PhD, right? Mm-hmm. That you need to trust other people doing their work. And trust is a very, very important thing, right? Control, yes, you need to be at least able to deduce if something with the results someone gives you is wrong, or figure out if something is a bit fishy, too good, too bad, for example. But trust in other people is something you learn and you need to learn. Otherwise, you'll be stuck in the loop of doing everything on your own all the time. This doesn't lead to too much progress, I think. So trust is something I would say you've got to learn.
Yes, we had one situation when we was together in a lecture and we worked in a project together, and it was called MobRec, I remember. And I think it was 4 people or something, but it was really important to everybody has his part in the project, and we have some points of time where we had to deliver the current state of the project, and we need to deliver. And so you learn quite early, and I think this is valuable also in the time of a university, how you can figure out this trust thing, né? Because if you are in a project environment, you need to work together in some way, and you see people are performing differently. But this is something, I guess, that is needed as a pathway through to be capable later on to use this information to build networks in your surrounding where you can trust to the people, because they have they give you the sign, the indication that they are trustworthy. And so this is something interesting. And okay, cool. So for me, I was thinking about, so your brain has changed in the years in the university, and you also learned later on in your PhD to trust to other brains and to work with them together. And this is something fundamental, I think, in human mankind. We already figured out in the last thousands of years. And now there's a new tool coming in. It's called AI. And you also said us before, doing the hard things is shaping our brain. And what are your thoughts around that topic when AI is now coming into university and every student can use tools like that quite easily to do the things?
I mean, it's a very broad topic. So I'm going to focus on maybe 2 things. So doing the hard stuff and yourself. And this is one thing that particularly shapes the job of a teacher or a professor now. So back in the day, professors were basically the holders of knowledge, right? Yes. They were up in their ivory tower and they had all the knowledge. Today, with access to the internet and to advanced generative AI models, we're not the holder of all the knowledge in the world, right? We're not this bottleneck that gives our knowledge to the students. But our role changed, and the role changed mostly towards us being coaches. And as a coach, something like a personal trainer, right? You can go to the gym on your own and work out, and every now and then you don't feel like going, and you don't go, and you take the easy way. You go back to the couch, eat some crisp, and progress goes down the drain. And the same thing is and a personal trainer keeps you how do you say,
consistent?
Consistent, and he builds a rapport with you, right? So you feel kind of responsible. You don't want to disappoint the person, and so on. And the same thing, I think, goes for teachers and professors these days. We need to build rapport. We need to motivate people to do things on their own, to shape their own brains, to not take the shortcut. And by this makes our job a lot more tedious, I would say, and a lot more personal. You need a lot more time investment for each of the students, I would say. And I fear that in that process, we will lose quite a few students, because there is cultures, and I don't mean that with any regard to region or race or anything. Cultures in the sense of a set of a mindset that you might learn due to your surroundings early on, that taking a shortcut or doing is smart. And this might be for certain things in life. This might be reasonable, might be a sensible thing to do. But when it comes to learning, there's no shortcuts. And with people that come from this mindset, from this background, I fear that we might lose quite a lot of them, because they take the shortcut. They want a degree. They need a shortcut to the degree. Yes. And so using the tools is very, very tempting in that regard.
Nice.
Cool. So your assignment is basically given away, right? You don't have to do it yourself, but you must be able to do it yourself. And it's hard to check that in an exam or anything these days. So without this missing milestones, this is going to be hard. And I fear we're going to lose quite a lot of people there.
For me, the question is, in a university context, you have the lecture period and you have the exam period. No? And in the lecture period, the student gets the information from the professor. He can use the AI tools he want to use. But when they're doing the exams, they are without any tools, though they have only their brain capacity. And what are your thoughts around that? Is it valuable for the student to use AI here to learn in their pace, in their frequency? And then when they are trained well with AI, they can maybe use the trained brain in the exam box quite well, because then they develop their brain capacity with the capabilities of AI. That is
absolutely. One of the funniest or most interesting things I experienced last year was the daughter of a colleague, and she is 7 or 8-ish years old. She can write quite proficiently these days, and she uses on her own volition, right? And she uses GPT models to create her own exams. So she likes to study already, and she's not going on and please solve my homework for me. She already does the smart thing. Ask me questions about what I gave you. And with that quiz, she speeds up her learning quite a bit. Yes. The same thing we can do, and the same thing I do. Yes. If I have to learn something new, and I mean, it happens these days all the time, especially if it's something basic, right? When I just need to touch up on another subject or relearn something about some foundational methods, I usually use AI to quiz myself, right?
Yes.
Because that's one of the ways people learn pretty quickly. And I would say this is a game changer, or can be a game changer. But if you do it the other way around, you take the shortcut, please do this, give me the solution, you won't learn. And this is like really, really a hard thing.
I just have one picture in my head. When you train the AI, the model, and you need a big amount of energy normally to train the network, that everything works quite well. And if you make the release of the model can be open sourced, the model can be packed in a small device, the model is lesser energy consuming in the use. But to train the model at front, you need a lot of energy. And I think to use here a shortcut in the human world just is not possible, because you don't train your brain. And you see it also in the AI field. To train the model, the energy is necessary. It's comparable, no? Yeah,
absolutely.
And I heard the word steal the weights, and I see that there are two currently two solutions in the AI field. Some are open source, the models and everything, and some are doing it protected and not open source it. And do you have some thoughts? This is now a little bit bigger perspective, but because in my case, I like to share knowledge, because knowledge is the only source I think is not getting lower in value. It's only getting higher in value for the humanity, how much often now we are using it. And do you have some thoughts around open source the models and not open source the models? Can you share there some knowledge from your perspective? Some advantages of that and some disadvantages, what you think?
Sure. Let's start with open source, right?
Yes.
In computer science, open source has a big tradition. Our most important operating system is Linux, and Linux is developed in open source. Mm-hmm. It also makes things a lot safer. A lot more people, a lot more eyes look on the code and see if there might be some flaws. Mm-hmm. Also, we see a increase in development speed because there's so many interest groups, and a company must go along one path, and the path is business driven or revenue driven, let's say. Mm-hmm. And there's a lot of use cases outside that won't drive the revenue of that company quickly enough, for example. Mm-hmm. So it won't go into that. And in the case of software, well, there's an interest group, and if it's large enough, there's always a couple of people that will start developing upon that. Mm-hmm. And same goes with open source models. The research community, there's loads of smart people in universities that can start developing custom solutions, custom models, adapted models to certain problems that a huge company like, say, Meta or OpenAI is not interested in. So they humanity loses all the brain power of those PhD students if there is no open source models. And I think that's also the reason, or one of the reasons, why also marketing and so on, while some companies release open source models, because in overall, it speeds up the progress. More people can work on related problems. Like building foundation models is very expensive. So it's pretty much limited to a handful of companies in the world. Most of the tech companies can do it. They have enough resources. They can pay people well enough to get these things done. A university like TUM will not be able, and it's the most successful, I would say, or it's the highest ranked university in Germany. They won't be able to train their own foundation model that has 70 billion or 400 billion parameters. They just don't have the compute. They just don't have the resources to do that. So therefore, I think open source is super valuable, especially when it comes to niche problems, developing AI away from just this foundation models, from this general purpose use cases, towards specified models, towards certain problems. I understand why there's closed source, and that is mostly, I would say, from a product-driven perspective. If you are
or to earn money afterwards, or what do you think?
Yeah, to earn money.
Okay.
Right. What people often miss is that the models are part of the software that's delivered. So I think is especially interesting with the release of GPT-5 a couple of days ago. I think now the last person on Earth understood that GPT-5 is more software than a model. You access the model through an interface, through a text interface, and that text interface, you cannot pick the model even these days, right? There is a software or another model that picks the model for you. So we are interfacing a software, a product, rather than a model. Whereas Llama or Llama, however you want to call it, 3.2, it's just that. It's just a model, and that's what open source is, right? If Meta releases a Meta chat or a Facebook chat, that's their product. That's their chat GPT variant, so to say. And there's a lot of interesting things, or a lot of interesting software you can build using these models behind some kind of interface. But we are actually not directly working with the model, but with the software that uses the model, or a couple of models. So from a commercial perspective, I totally understand why you wouldn't release your model or the structure, because you pay for a ChatGPT license, and now the company decides that you only get answers from the cheap model, but you want answers from the best model. But that's taken away from you, that decision. So I think a lot of people are very unsatisfied with this development these days. But for most people, they won't understand this, because also we cannot look into that. So they decide on a commercial basis, where do they route your query, to which model, how much money do they basically burn to answer your request, your query.
Interesting.
So from that, I totally understand why you would go closed source.
From commercial perspective, to save money in the company, in the use case of everybody's using your money to burn the questions. Okay.
Yeah. Also not being how do you say, transparent with what model actually gave you the answer, because that decides how much money you spent on that query or answering that.
I just figured out Gemini. I just used it 8 weeks ago. I started using it heavily 8 weeks ago, and I was surprised about the difference between, the main LLMs I'm using are Perplexity. I don't like ChatGPT so much. I'm using Gemini. I'm using Claude, and these are the LLMs I'm using a lot. And I was surprised about the connectivity, the easy connectivity of Gemini, because there is the cloud storage of Google G Drive, and the intelligence of every document what you put in there is, of course, available to work with Gemini together. And the ecosystem Google built up here is not, in my point, comparable with a ChatGPT or with a Perplexity or some other. Because if they are playing the cards right, my feeling is that Google has built up here an ecosystem. What is also the Chrome browser is so settled. Everybody's using some Android phone. So 50%, I don't know exactly how much in Europe, but I would say I'm not sure about, but a lot of people are using Android phones in Europe, a lot of using iPhones, but they have so much advantage in the market, and if they are using it right, they have a really good step ahead before the other LLMs. What are your thoughts around that, to use Gemini in this field, or is it not good for you in your perspective as a comparable tool to ChatGPT or some other, like you mentioned before?
I think it gets harder and harder to compare these models, because, as mentioned before, you mostly interact with the software, right? All the connections to your Gmail, to your Google Drive, and so on, this is software.
Yes.
That's not per se the model. So there is also connectors for ChatGPT that can directly access your Gmail. I think same is true for Claude, and probably the same is true for other things. It's just some piece of software that gives some form of access to your some or private documents. So going back on that, I think I was quite surprised that Google wasn't leading in the AI race early on. What they already know about people, what they already have as data, or also structured data, right? Or semi-structured data, especially their search graph and how knowledge is already connected through their basic products.
Yes.
I thought that would put them at a competitive advantage. But it seems that, especially in the Gen AI part or era, it didn't. Why that is? Well, you probably also read The Innovator's Dilemma by Christensen. It's probably that. At first, it didn't satisfy their growth expectations or their growth needs. And they only got going after the release of ChatGPT. And so early 23 or late 22, early 23, I think, was the release of ChatGPT. And this is when those models were first put into software that really, really impressed people. And that was when Gen AI basically was put on the map. And ever since, all the craze happened. But still, very good AI people worked at Google, and to this day are working at Google. Just, the basic algorithm behind all of the GPT models, attention, so scaled dot product attention, was developed at Google. So they have good capabilities. They have very smart people working there. They just needed a product vision, I think, to get going. And they got it through someone else. So now they're not the leader. Now they're a follower. But as you see, through Gemini, they're fast following.
They are really fast. It's amazing what they are doing. The capabilities are amazing. Thank you for your thoughts on that topic on Google and Gemini. It's cool. For me, I was thinking about what are the values of using AI in a company. And in my research, I figured out when you are talking about the solutions of AI in a company, you're thinking about intellectual property. What are the things you can build up in the company to protect? And I figured out there are 3 parts. Of course, the prompts, everything what you are talking to the machine in some way of interface. Then there are the examples. These are the things you want to get out when you are talking to the machine, and they're giving something like a benchmark where you want to go. And there are the evals, and the evals are evaluations. They are more softer, and they are more, I would say, because when you are working in companies, quite often there are human interests involved. And when you are a leader in a business unit and you have your own KPIs at the end of the year, it doesn't matter if the machine is smarter than you. If your KPIs are not matching the things that the machine is giving you, you are not using the machine in the right way. So the evals are more are the humans using the machine in the right way to fulfill the purpose of the company. And this is how I would describe it with my words. It's not the maybe scientific description, but I would describe it. It's more softer. And these are the 3 things. So from the prompts, the evals, and what are the third part? I forgot it.
Said prompts, examples, evals.
Yes, prompts, examples, evals. Thank you, Sebastian. And so these 3 things are the IP in the company to protect. And because I was researching that, and I found on Y Combinator a lot of information about those topics. And because there are companies who are sharing their prompts, there are companies who are protecting their evals, and they're not sharing the examples. But if you have all these 3 parts, you can copy the value creation of a company. And did you have some thoughts around that? Because the models are getting accessible for everybody, no? But in a company, you have so many parameters, what you need to think through. And do you have a glue around that topic? Do you think there are these 3 more of that, or is it not correct? What are your thoughts around that?
I'm not sure about how valuable prompts are these days. Because there is prompt rewriting algorithms these days. There is AI models that can rewrite your most basic prompts to then prompt a model again. So I'm not sure how valuable the prompts are. What's absolutely important is that you get good examples. And I would also say that the examples are, to a degree, your business secret. But to be honest, those examples are also usually not very complex, right? You put in a prompt, you put in an example of and you also then show the machine what you want as an output. ideally, those are curated. Ideally, over time, the longer you use your machine, the more examples you're gonna get. And once you have enough, you can even start fine-tuning your model, right? So not then using the general purpose model, say any form of Gemini, any form of Llama, and you give that your prompt, but you then use your specific version of Llama and fine-tune it. Do a optimization towards your examples. So the model per se isn't only a general purpose model, but also aligned with your business needs. And so I think the training data, the new training data, are the examples. And the more you work with AI, the more good training or the more good examples you should generate. And those are some things you need to keep track on. You need to store, and then you can use them to increase or improve the model for your use case. Up until the point where you're just prompting, I don't even think that the examples are that valuable. Because how many examples do you have when you start out? 10, 20? And how many can the model even process in their context value in their context window? A couple. And then it should solve one of the tasks you give it, given those prompts, given those templates. And only once you have human evaluated examples, quite a lot of them, then you can start actually adapting the model. So this is where those examples become very valuable.
And the adopting of the model, you think, is in future some IP, this new adopted model is some form of IP in the companies. So you would say this 3 plus 1 part in the future.
Yeah.
Okay, cool. Thank you.
I mean, there is other things that will go into that, but I think getting your own data, your own training data, your own optimization data, let's say, that encodes your company's preferences, your use cases preferences. That is something that is going to be very valuable, especially once people reach the end of just few shot prompting, right?
Yes. But when you want to iterate on the model, it's also, I think, really high energy uses. You need a lot of compute for that, or?
Yes and no, right? Okay. There is very efficient training methods for that. So let's say, I mean, we can go into the bit of the details, but it's you stop me when I go too far, right?
I like Sebastian. It's really interesting to me. I like it.
All right, but you just stop me then. All right.
Yeah.
So overall, those models have a certain size. You can calculate that easily in your head. So a model, let's start with the 7 billion, and let's do all the simplifications that we want to use. So 7 billion parameters means 7 billion floating point numbers. A floating point number is the way a computer stores a number, a floating point number, right? That is encoded in 32 bits of data in general. That's the full precision, what we say. So you can just imagine it as kind of rounding, okay? So 32 bits rounds your number to 32 bits. You can also do that with 16 bits, 8 bits, and so on, right? Which has a rounding effect. So you get less precision when you store those weights. But with the less precision, you also need less compute and less space. Okay, so that out of the way. So you can go with the 7 billion model. And if you want to load this 7 billion model for just inference, so meaning you want to prompt the model, then you need to load this into your GPU memory. Typical GPUs these days for non-commercial use have around 16 gigabytes. So you want to load this, and we can calculate in our head 7 billion parameters times 32 bits or 4 byte. This gives us around 28 gigabytes ish. That doesn't work, right? So what you quantize the model. So you round all the weights, and then you can load it on the model. So instead of 32 bit, which we need 28 gigabytes, we just need 14 gigabytes. We just half the precision. And then we can load it. That was one way to achieve this. And many of the modern models, especially for end or edge device use cases, for example, your iPhone, they are already trained on quantized or at least quantization aware training procedures. Okay, so they do not lose too much precision when using them with just a 16-bit model. Okay. So that way, we enable companies or people with user-grade hardware to run those models. Mm-hmm. So training is a bit more expensive because you need to basically store a copy of the model again. So the gradients that we need to use to optimize the state. So we roughly factor 3 to 4 of memory consumption during training. So that's a big bottleneck, but you get that for crowd from the cloud quite easily. Mm-hmm. So in that way, we can load the model, then maybe quantize it, reduce the memory footprint of the model, and then fine-tune it, train it. And that can be done in very few steps. So we don't need weeks or months, but because we only have like 1,000, 2,000, 3,000 training samples, that can be done in a matter of hours. Mm-hmm. And we don't need to train the whole model. There are techniques that allow us to learn the updates only, so-called adapters, or if you ever hear it, LoRa, low-rank adaptation. Remember a bit from your linear algebra class, you can reduce the rank of a matrix by multiplying it, by multiplying it with a smaller rank one, right? You basically do some compression, and then you can do some expansion again, right? Mm-hmm. So remember m times n, you can do n times whatever, n times x, right, from the rank of the matrices, and that reduces that. And so this way, you can use very little weights to update. So your general purpose model remains untouched. You then fine-tune your model using these low-rank adaptation modules that do need only very little memory. Mm-hmm. And they basically hold the updates from the general purpose model towards your specialized model. And so that way we can enable companies to train their own models more easily. Less memory intensive, less energy intensive, so to say. So there's techniques that allow us to do that.
Is that in the current state only available for universities and big companies, or is that something you would say that's also in the commercial market available for companies?
I mean, if you have the knowledge to do that, you can easily do that, right? The main bottleneck, I would say, is people that have knowledge of those techniques and that can apply it. You can. So yeah. I would say AI is very much democratized. You can go to Hugging Face, download a lot of base models. There is a lot of software built around it that you can use to do the fine tuning. There is software that does this LoRa, which I just described. It's just an adapter. It's just a bit linear algebra around it. And the software for that is Hugging Face and PyTorch, for example. And building it is, for someone who's proficient, a matter of maybe hours. Then running it, of course, evaluating it. There is a long iterative circle to improving the models, especially with Gen AI, where we not only can rely on what's it called, quantitative analysis, right? Where some summary metrics, but you also want the output to appeal to humans, right? So we need this qualitative evaluation, and that takes a lot of time still. So I would say that is where the feedback loop gets stuck with most people.
I was surprised about Hugging Face. I was on this website and I was looking through the models, how much there is available and how good and well structured it is already.
Yep.
And it's so unknown. I think you are in your niche, you are an expert in this area, no? But it's for normal people, they just come from the market. They never heard about Hugging Face. And I think the skills and the knowledge of the people like you and your peers is so valuable these days, but there are so less people who are trained and get the knowledge of that. How should we bring this knowledge into the companies in Europe? I have no clue.
I mean, we're doing it to a degree. Every computer scientist these days, at least on a master's level, I would say, has some basic knowledge of AI, right? We train people to do it. So, for example, we changed the curriculum in Rosenheim. We have a bachelor's study for software engineers, and we now changed the curriculum to include AI, which we have a specified subject for that now. Plus, all the professors start integrating AI into their lectures. So this is a two-way thing. First, applying AI in your lectures, in your exercises, so to say. On the other, training people to have basic understanding of AI and like a overview of the landscape of tools that are available out there. And on the other hand, I mean, we also have, speaking for Rosenheim, and I think that is also true for many of the other unis in Bayern or Bavaria, we have a course just for applied artificial intelligence. So people right from the start learn these things. Semester 1, linear algebra and analysis. Semester 2, basics of AI, starting coding in Python. Semester 3, doing supervised learning, unsupervised learning, deep learning, and so on. So there is ways. We just started a couple of years ago. We now have the first graduates. So it gets going. And people are interested. So they are also interested in hiring those people.
So the one thing is you need to know that you need to hire people like that. If you don't know you need these people, you will not hire them. And the other thing is, are they available on the market? Is the second question then, if you know now you need them. And you said the first group is already finished. And this is really interesting for me because I think in my case, I did make the announcement. I think in 3 to 4 years we have lesser people 50% lesser people in the companies here in Europe because of the labor costs and stuff like that. And so currently in the market there is a huge, there are some layoffs going on, and because the economy is quite difficult, and I think it is needed. Like the technology always drive value creation, and I think these AI things is needed to fulfill the next phase, because I think the labor costs are too high here in Europe, and if these big companies want to be here in Europe with their production and with their companies, they need to find out to work with lesser people. And so these people are valuable in a company, but we also have to upskill the people that are in the company. Do you have a clue how this will happen? How this is possible?
I mean, to a degree, this is happening already. With now, let's rephrase this. It's already happening. Okay. I think there is a lot of regulatory pressure on people and on companies in Europe, especially when it comes to AI. And one of the good things about this pressure is it also pressures people to educate their staff about AI. So
nice, yeah.
One positive effect of the regularization is companies they want to use AI must make sure that the people they employ are proficient in AI.
Yes.
So this is one way that I would say the AI Act positively influences that in companies.
Yes, agree.
And this is, as I know from a company, I'm how do you say? I'm consulting. They basically give courses about these things to companies, and it's working quite well, right? There's a lot of demand for that.
Yes, agree on that. So you have already think this one way about the universities, and the other way around upskill the people in the workforce by an ongoing education or training by some external partners is the best way to bring up the level of AI skills in Europe.
Yeah.
Cool. I like, for me, I'm already thinking about, I have one last question. When you think about the comparison between maybe US, America, with the way they are going with AI and Europe, what are your thoughts? Are they going the right way in America they are quite, they are really fast growing this market. They are really fast growing in this market. They have something like a competition going on with China here currently, America against China. But they are really low regulated currently in America. And we as Europes are using quite heavily the products of the Americans. And I think we have, like we did it with Facebook, with Instagram, with all the other platforms. We are not thinking a lot about what's going on with our data here. And do you think that the way of the Americans, very fast growth, low regulation, or do you think that the way of the EU, strong regulation, and maybe some more energy protection and climate neutrality goals are more important for us in the future? What are your thoughts around that you can give us maybe here some perspective of from your side?
I mean, it's a prediction of about the future, and that is the main the main problem with that predictions, because it's about the future. So it's hard to say what will turn out best. I think Europe tends to be a bit strong on the regulation part, but is very precaution driven, or caution driven, I would say. Bit fear driven, maybe even. If that in the end might be even a competitive advantage, and in the end, I mean, later down the road, 10 years time or so, we'll see. I am a bit fearful that we might lose a lot of talent in the process, and that we might lose a lot of people that want to do things in that regard. The main problem why we cannot even copy the Chinese, or we cannot even copy the Americans, is we are still all singular countries. So we kind of have a common strategy, but it's not like the one China strategy where every person that can hold a pen or has a certain scoring a test is put into an AI study course and driven to pursue AI in China. And you can see that the number of publications at big venues, at big conferences regarding AI is through the roof in China. So I think ACL, one of the biggest conferences, has like almost 50% of publications now coming from China, with a big drop from publications coming from the US. Also because a lot of people leave the US in academia due to Trump. That's just what it is. So we have a strong drop. I think 10 percentage points, over 10 percentage point less publications from the US, which is a wake-up call. Because there is also research outside of the big companies, and also big companies will be relying on international talent. And that was always the strength of the US, because they could just buy talent. There's a lot of venture capital, and they bought the good people. But China has over 1 billion people, so they are bound to find a couple of capable people, and with a strong strategy behind that, they can build their own talent pool, so to say. And they are quite successful with it, as we can see now. So what's best, caution-driven or regulation-driven versus complete open markets or one China strategy? I'm not sure. We'll see. I think one thing that is a bit overlooked these days is that one of the founders of OpenAI, Ilya Sutskever, he founded his own company. He left OpenAI to build his own startup that had, I think they already got in $1 billion of funding, which is, I'm not sure about the name. What's it called? Safe AI or something. Let me. So I think Safer AI or Safe Super Intelligence. Okay, and he left OpenAI about worries on the effect that AI or a possible general artificial intelligence system might have on societies without regulation, without proper precautions. And what we can see is that without proper precautions, those systems, they do things we don't want them to do. For example, like putting out nationalistic slurs or racial slurs, and they just do what they're trained on. And if you train your model on, let's say, Reddit content, they're bound to see a lot of racist stuff. And so we need to kind of regulate for this and build safety measures. So in the US, we now have a company, Safe Superintelligence, that tries to do this. In Europe, we try to regulate this from the start. What will be the right way? We don't know. We don't know the effects. I think through historic precedents with technology, I think people in Europe are a bit more cautious overall. But only time will tell whether we'll be more successful.
Yes, I see. Okay.
But we have to make sure about also with regulations. Research institutions are not regulated as much as, for example, companies. So there is an incentive also still inside of Europe to do research in what would be a forbidden practice among the AI Act. So we can still do research in that regard. We just cannot build a commercial product with it.
Interesting.
We can do live tracking of facial features or of people. We are allowed to do that in research. We are not within companies.
Interesting. So I'm positive. So for me, it's I see in our generation, and I'm really happy about this talk today with you together, to see how learning impacts brains and shapes the future of our society. And when I see how you growth in the last 20 years happened, and I see how you do take impact, or you have your impact on the students in the University of Rosenheim there, and this makes me more confident for the future here in Europe also. And I think sometimes it's not the best to be fast. Sometimes the European approach was more reliable for future, and I like it to keep watching the world, what's going on there, but to be a bit independent is never be a bad thing, and to use our own thoughts around the topics was never bad. And I like to have this conversation with people like you who are really deep in the field, and I learned a lot today about the topics, and it was not too deep for me. I enjoyed it a lot, Sebastian. And I would say from my side, I'm really happy and thankful for the work you are doing with the students there, because I think it will shape the future of the environment we are living here in Europe for the next 10 to 20 years. And from my side, thank you very much. It was a pleasure to talk to you, and it was a deep dive with you, Sebastian, on AI and the power of learning. Do you like to say something, some last words to our audience today?
No, thanks for having me. It was a pleasure talking to you.
Yes.
I'm also trying to be positive about our future prospects. And I think we have great people, and we also have great people coming into Europe working on the topics. So we'll see what the future brings. Let's keep positive.